After considering one variable at a time, it is usually relevant to start investigating relationships among them. The simplest way of doing it is using bivariate statistics, which consider two variables at a time. The most common bivariate statistics is correlation, which is measured by Pearson's R. It measures if two variables show a similar pattern, that is, they move in a similar way. The correlation coefficient may assume values between -1 and +1. +1 means perfect direct correlation, that is, the two variables move in the same direction. -1 means perfect inverse correlation, that is, the two variables move in opposite ways. 0 means no correlation. In this example from the IPS project, we see the correlation between the sales and the number of employees of the companies in the sample. The value of 0.69 means that the correlation is direct and pretty strong. When we consider at least two variables, we can start testing our research hypothesis. Statistics provides us with a broad range of tests that we can use for this purpose. Depending on the type of variables we have, we can choose between two groups of tests that are called parametric and non-parametric tests. It is beyond the scope of this course to provide an in-depth and exhaustive presentation of statistical tests, but they are extensively treated in any statistical course. Here we see a brief overview. These tests are included in any statistical package, so what we need to do is to know which test we need to use in each case and how to read the output. Parametric tests can be used when data meet a number of requirements. Scales are interval or ratio. Observations are independent. Observations are drawn from normally distributed populations. Populations have equal variance. An example of parametric test is the Pearson test of correlation. We have already seen the Pearson's R, but how can we know if the value is significant? The test tells us if the R is significantly different from 0, which means that the data are actually correlated. In parametric tests, we usually formulate a null hypothesis, H0, in this case that R is equal to 0. If we obtain a low probability for H0, at least lower than 5%, or better if it is below 1%, then we can reject it, and so conclude that the alternative hypothesis, H1, is true. In the IPS example that we have seen earlier, we can reject the H0 because it has a probability lower than 1%. Another common parametric test is the t-test, for testing whether two groups of respondents have significantly different means for the variable of interest. The null hypothesis is that the two groups have the same mean. So, if the result is below 5%, we can reject the H0 and accept the H1, so we can conclude that the two groups have different means. In this example from the IPS project, we see the mean of the number of employees of the companies from Finland, 1,855, and Italy, 278. The H0 is that the two values are equal. With the t-test, we obtain a p-value well below 1%, so we can reject the H0 and conclude that the two values are significantly different. A third common parametric test is the analysis of variance, or ANOVA, which tests the difference in the means of a variable among multiple groups. Extending the previous IPS example, ANOVA is the test we need when we consider 4 countries and we want to test whether the mean number of employees is significantly different across them. The H0 is that all 4 countries have the same mean. If we reject the hypothesis, it means that at least one country has a mean different from at least another one. Non-parametric tests, instead, are used when our data do not meet the requirements for parametric tests. Non-parametric tests, indeed, can be used also with nominal and ordinal scales, do not require normal distribution nor equal variance. In some cases, they do not even require independent observations. For example, when we consider 2 categorical variables at the same time, we can calculate the frequencies of each combination. For example, we may want to see how our sample is distributed according to both country and industry, and cross-tabulate the frequency of occurrence. But how can we understand if the 2 variables, country and industry, are independent or instead they are related? We can run the chi-square test, which is a non-parametric test. There are many more tests, both parametric and non-parametric, which can be useful to test many hypotheses.